Hello, everybody. I welcome all of you to this online education by Department of Mathematics, MK Bhavnagar University, Bhavnagar. I will teach you paper number 101, whose title is Real Analysis, and myself, Dr. P.I. Andharia. Let us uh, see what is real analysis. Real analysis is a subject based on some fundamental concept of mathematics that you have studied during your school time, like set theory, functions, relations, and real number systems. So, if you uh, sound in these topics, that is set theory, functions, relations, and real number system, then you will not having any type of difficulties in understanding this subject. You will study four theory subjects in each semester and two practical subjects in each semester. Practical subjects depends on theory subjects itself. So real analysis is one of this one of the our theory subject, and its practicals will fall in paper number 105A. 105A is based on practicals based on paper number 101 and 102, that is number theory. So we will see this subject theoretically as well as practically. Practically means you have to solve the examples which are based on topics we have studied in theory. So with each and every theory topic, if there are examples available, then I will show you uh, the method of solving that type of examples. And more, you have to do more examples for practice, and that will cover under practical sessions. So let us start our subject real analysis. Each and every subjects are divided into 4 units, 1 to 4. So our syllabus will contain 4 units. Out of them, let us start first unit. In almost all topics, we will see definitions, related examples, and some of the results depends on the definitions and examples. First, let us see a topic of algebra of sets. Here is definition of algebra of sets. Let X be any non-empty set. Non-empty set means at least one element is there in this set X. This notation you know, P of X, power set of X. It is the set of all subsets of X. Take any subset script A of P of X. P of X contains all subsets and script A is subset of P of X. So obviously script A also contains some of the subsets of X. So script A, which is a subset of P of X, is called an algebra of sets if there are two conditions satisfied. First condition, if A and B belongs to script A, then A union B also belongs to script A. Second condition is, if A belongs to script A, then complement of A is also belongs to script A. This is the notation for complement of A. Tilde sign over A, that is complement of A. So two conditions are satisfied, then it is called algebra of sets. Two conditions are union of two members of script A is also a member of script A, and complement of a member of script A is also a member of script A. Let us see some examples. For any non-empty set X, if you take script A1 is equal to the set of two members, null set and X itself, and another set script A2 equal to power set of X, that means whole the collection of all the subsets of X, then both of these two, script A1 and script A2, are always algebra of sets because they satisfies all both of these two conditions. Let us check in the case of script A1, if we take these two sets A and B, that is null set and X, then union of these two sets is X. So X also the member of script A1. And complement of phi is X, belongs to A1. Complement of X is phi, null set, also belongs to A1. So both the conditions are satisfied. So script A1 is an algebra of set. Similarly, if you consider script A2 equal to P of X itself, that means set of all subsets of X, then obviously if AB belongs to script A, then A union B is again a subset of X because AB are subset of X. So A union B is again a subset of X, and power set of X contains all subsets of X. So again A union B also belongs to A2, and complement of A is also a subset of X. So again it is a member of P of X. So obviously A1 and A2, if we take A1 equal to phi and X and A2 is power set of X, then both are always algebra of sets. And these are always algebra of sets. Therefore, they are called trivial algebra of sets. For any non-empty set X, these two are always algebra of sets. Another example, X equal to a set, X is a set of two members A and B. Then if we take script A is equal to the collection of two singleton sets, singleton A and singleton B, then it is not an algebra of sets. Because if we check the condition, then union of these two sets, singleton A and singleton B, union of, if we take union of these two sets, then it becomes AB, set of two members AB, and it is X. It is not belongs to script A. So first condition is not satisfied. Therefore, script A is not an algebra of sets. Third example, if we take X equal to the set of two elements A and B, then possible algebra of sets are script A1 is phi of phi and X, and script A2 is P of X. We know that both are trivial algebra of sets, so these two are always algebra of sets. There is no another algebra of set for this set. So if you are having two members in your set, then there are only two possible algebra of sets, and both are trivial algebra of sets. If you take three members in your set X, A, B, C, then possible algebra of sets are obviously two trivial algebra of sets, that is A1 is equal to phi and X, A2 is P of X, these two are algebra of sets. Another possible algebra of set is A3 is equal to phi X singleton A and BC, set of BC. If you check these conditions, then you will find that for phi X, no problem. Complement of phi is X, complement of X is phi, union of phi and X is X. And if you take union of these two sets, A and BC, then ABC, you will find ABC, that is nothing but X. X is a member of this A3. So union of these two sets is also a member of A3. Complement of singleton A is BC and complement of BC is A. So complement of each and every set also is a member of A3. Similarly, you can find another algebra of sets A4 is equal to phi X, B and AC, singleton B and AC. And A5 is phi X, singleton C and AB. So there are five possible algebra of sets for this set of three members A, B, C. Now this is for your homework. X equal to A, B, C, D. There are four members. Then number of possible algebra of sets is 15. So you have to find out all these 15 algebra of sets. Some of the remarks are given here for algebra of sets. Let X is not equal to null, that is X is non-empty set. Script A is script A is subset of power set of X, and it is given that script A is already an algebra of sets. So it satisfies all the both the conditions of algebra of sets. Then we have to show that phi and X are always belongs to script A. See, it is given that script A is an algebra of sets, so it satisfies both the conditions, first and second condition of definition. So if you take any set in script A, then its complement is also a member of script A. So let us take A belongs to script A. Then by condition number 2, A complement is also belongs to script A. And by condition number 1, union of two members is also a member of script A. So here we have two members, A and A complement. So union of A and A complement also belongs to script A. Now union of A and A complement is nothing but X. So X belongs to script A. So we have proved that X is always belongs to an algebra of sets. Now we will show that null set is also always a member of algebra of sets. Suppose, so now, okay, now we have already proved X belongs to script A. So take X belongs to script A. Then by condition number 2, complement of X also must be belongs to script A. Complement of X is nothing but null set. So null set also belongs to script A. So we have so that X and null set are always member of script A. Another result, if AB belongs to script A, then A intersection also belongs to script A. Given that AB belongs to script A and script A is algebra of sets, so A complement and B complement are also belongs to script A. A complement and B complement are belongs to script A. So union of A complement and B complement also belongs to script A. By condition number 1. Again, if we use second condition, then complement of union of A complement and B complement is also belongs to script A. This is nothing but A intersection B. Because how to find out complement of first set? Here it is union, so in complement it becomes intersection, and complement of other set. So complement of A complement is A intersection, complement of B is B. So A intersection B belongs to script A. Now we know that union of two members of script A is also a member of script A. If you take another member, third member, then again if you take union with this member, it is also belongs to script A. So finite union is always a member of algebra of set. So A1, A2, A3 up to An, finite number of sets. If you are having finite number of sets in script A, then union of AI belongs to script A. This is finite union. Similarly, we have proved that intersection of two set is also a member of script A. So intersection of finite number of members is also belongs to script A. Now let us see the third result. If AB belongs to script A, then A minus B also belongs to script A. Given that AB belongs to script A, this implies A and B complement also belongs to script A. This implies A intersection B complement also belongs to script A. Now A intersection B complement is nothing but A minus B. So A minus B also belongs to script A. So there are 5 remarks, 5 short results. Now let us see one example. Let X is non-empty set, script A is subset of power set of X. with this condition, A minus B belongs to script A for every AB belongs to script A, and a complement belongs to script A for every A belongs to script A. Then so that script A is an algebra of sets. So here in this example, we have given two conditions and we have to show that script A is an algebra of sets. Script A algebra of sets આપેલું નથી, આપણે પ્રૂવ કરવાનું છે કે એ algebra of set છે, એટલે કે algebra of set પ્રૂવ કરવા માટે બે કન્ડિશન પ્રૂવ કરવી પડે, ફર્સ્ટ અને સેકન્ડ. Out of this, there's two conditions. Second condition is already given. A complement belongs to A for every A belongs to A. So we have to prove only one condition. Let us prove that. Let AB belongs to script A. There are two sets. Then we have to show that A union B also belongs to script A. AB belongs to script A. By condition number 2, A complement also belongs to script A. So A complement and B belongs to script A. Now by first condition, difference of these two sets also belongs to script A. So difference of A complement minus B belongs to script A. A complement minus B is nothing but A complement intersection B complement. So A complement intersection B complement also belongs to script A. Again using second condition, complement of member, that is A complement intersection B complement, also belongs to script A. So it implies A union B also belongs to script A. Second condition is obviously given, also given that A complement belongs to script A. So script A is an algebra of sets. Both the conditions are satisfied. So we have seen algebra of sets. Now we'll see the definition of sigma algebra of sets. Not only algebra of sets, but sigma algebra of sets. In sigma algebra of sets, there is another condition, third condition. Two conditions are as it is, and third one is extra condition. So let X be any non-empty set. P of X is the set of all subsets of X. Then any subscript A, which is subset of power set of X, is called the sigma algebra of sets if these three conditions are satisfied. First two are same as algebra of sets, and third one is if AI is a sequence of sets in script A. मतलब સ્ક્રિપ્ટ A ના જેટલા સેટ લેવા હોય એટલા તમે લઈ શકો AI માં, આ સિક્વન્સમાં. તો એ તમામનો યુનિયન ઓફ AI also belongs to script A. The arbitrary union of members of script A is also a member of script A. If this third condition is also satisfied, then the set X is called sigma algebra of sets. તો સિગ્મા અલ્જીબ્રા ઓફ સેટ્સ માં જે ફર્સ્ટ ટુ કન્ડિશન્સ છે તો અલ્જીબ્રા ઓફ સેટ્સ ની જ છે. તો સિગ્મા અલ્જીબ્રા ઓફ સેટ ઓબ્વિયસલી અલ્જીબ્રા ઓફ સેટ ની કન્ડિશન તો સેટિસ્ફાય કરે જ છે. So every sigma algebra of sets is an algebra of sets. અગાઉ આપણે એક રિઝલ્ટ જોયું છે કે યુનિયન જો બિલોંગ કરતું હોય અને કોમ્પ્લિમેન્ટ બિલોંગ કરતો હોય તો ઇન્ટરસેક્શન પણ બિલોંગ કરે છે. તો અહીંયા યુનિયન ઓફ એઆઈ બિલોંગ કરે છે એમાં, તો ઇન્ટરસેક્શન ઓફ એઆઈ પણ એમાં બિલોંગ કરે. અહીંયા સેકન્ડ કન્ડિશનમાં ટાઈપિંગ મિસ્ટેક છે. અહીંયા a complement, only a complement is there, not a complement union b. I will rectify this error, but right now you read here a complement belongs to script A. Now some results we prove. First result, first theorem. Given any collection script C of subsets of a set X, X is non-empty set, there is a smallest sigma algebra of sets containing script C. કહેવાનો મતલબ શું છે? કોઈ એક નોન એમ્પ્ટી સેટ X આપેલો છે, એના સબસેટ્સ નું કલેક્શન કોઈ પણ સબસેટ્સ નું કલેક્શન સ્ક્રિપ્ટ C છે. થોડા સબસેટ્સ લઈ લીધા X ના સબસેટ્સ, એટલે C is a subset of power set of X. So there exists a smallest sigma algebra of sets containing C. આ C આખો ઇન્ક્લુડ થઈ જાય અને બીજા પણ સેટ અમે ઉમેરવા પડે તો ઉમેરીએ. એવી રીતે એક તમને સિગ્મા અલ્જીબ્રા ઓફ સેટ્સ મળે અને એ સ્મોલેસ્ટ હોય. એટલે આવા જેટલા સિગ્મા અલ્જીબ્રા ઓફ સેટ્સ મળે એમાંનો એ સ્મોલેસ્ટ હોઈ શકે. તો આ રિઝલ્ટ આપણે પ્રૂવ કરશું અને આવું જ રિઝલ્ટ આ સિગ્મા અલ્જીબ્રાની જગ્યાએ અલ્જીબ્રા ઓફ સેટ્સ કન્ટેનિંગ સી વાળું એક રિઝલ્ટ છે જે તમને હોમવર્કમાં આપું છું. એટલા માટે કે આમાં સિગ્મા અલ્જીબ્રામાં 3 કન્ડિશન છે ને અલ્જીબ્રામાં 2 જ કન્ડિશન છે, એટલે આનો જ એક આના પરથી જ તમને બની જશે એ અલ્જીબ્રા ઓફ સેટ્સ વાળું રિઝલ્ટ. તો અલ્જીબ્રા ઓફ સેટ્સ વાળા રિઝલ્ટમાં તમારે પહેલી બે કન્ડિશન જ પ્રૂવ કરવાની છે, થર્ડ નથી કરવાની. આમાં 3 કન્ડિશન છે એટલે આ હું તમને કરાવું છું. Proof. Given that script C is subset of power set of X. Now consider the class script F equal to, it is the collection of script B which is subset of power set of X, where B is sigma algebra of sets and B contains C. તો C કન્ટેન કરતા હોય એવા તમામ સિગ્મા અલ્જીબ્રા ઓફ સેટ્સ લઈ અને F માં ભેગા કરી આવે. તો F પોતે જે મેમ્બર્સ કન્ટેન કરે છે એ શું છે? સિગ્મા અલ્જીબ્રા ઓફ સેટ્સ, અને એ બધા જ મેમ્બર C ને પણ કન્ટેન કરે છે. That is, F is the class of all sigma algebra of sets of X containing C. Now let us take script A is equal to intersection of all such script B, where script B belongs to script F. So script A is the intersection of all members of script F. તો સૌથી પહેલું આપણે પ્રૂવ કરશું કે આ જે સ્ક્રિપ્ટ આપણે ડિફાઇન લીધો છે એ સિગ્મા અલ્જીબ્રા ઓફ સેટ્સ છે. તો સિગ્મા અલ્જીબ્રા ઓફ સેટ્સ હોવા માટે 3 કન્ડિશન બતાવવાની છે. ત્રણ કન્ડિશનમાં ફર્સ્ટ કન્ડિશન એવી છે કે બે સેટ લઈને એનો યુનિયન પણ એમાં હોવો જોઈએ. તો our claim is A is an sigma algebra of sets of X. Let A B belongs to script A. Script A શું છે? Intersection of members of script F. So that is A B belongs to intersection of members of script F. તો આ બધાના ઇન્ટરસેક્શનમાં હોવું મતલબ દરેક સેટમાં હોવું આવે, કારણ કે ઇન્ટરસેક્શનમાં હોવું એટલે બંને સેટમાં હોય તો જ ઇન્ટરસેક્શનમાં આવે. યુનિયનમાં હોય તો બેમાંથી એક સેટમાં હોય કે કોઈ પણ એક સેટમાં હોય તો પણ યુનિયનમાં આવી જાય, પણ અહીંયા ઇન્ટરસેક્શન છે. તો A B belongs to B script B for every script B belongs to script F. દરેક સ્ક્રિપ્ટ બી માં હોય તો જ એમાં આવશે. હવે દરેક સ્ક્રિપ્ટ બી તો શું છે? સિન્સ ઈચ સ્ક્રિપ્ટ બી ઇઝ સિગ્મા અલ્જીબ્રા ઓફ સેટ્સ. તો સિગ્મા અલ્જીબ્રા ઓફ સેટ્સ હોય તો એક બધી કન્ડિશન સેટિસ્ફાય કરે. તો કન્ડિશન એની કેવી છે? એક ફર્સ્ટ કન્ડિશન યુનિયન પણ એમાં હોવો જોઈએ. તો A B belongs to script B હોય તો A union B also belongs to script B. This is true for each B in F. દરેક બી માટે જો આ સાચું હોય તો ઇન્ટરસેક્શનમાં પણ હોય, કારણ કે દરેક બી નો મેમ્બર બનશે A union B. તો A union B belongs to intersection of B. હવે ઇન્ટરસેક્શન ઓફ બી તો શું છે? બાજુ એ સ્ક્રિપ્ટ છે આપણો, એટલે A union B belongs to script A. For every A B belongs to script A. Call this result 1. Now we will prove second condition. To prove second condition, let us take one set A belongs to script A. Script A means intersection of B. તો ઇન્ટરસેક્શનમાં હોવું મતલબ દરેક બી માં હોવું. તો therefore A belongs to script B for every B belongs to F. દરેક બી જે છે તો સિગ્મા અલ્જીબ્રા ઓફ સેટ છે આપેલું છે. સિન્સ ઈચ બી ઇઝ સિગ્મા અલ્જીબ્રા ઓફ સેટ, તો એ કન્ડિશન સેટિસ્ફાય કરે, એટલે એ કોમ્પ્લિમેન્ટ બિલ ઓલ્સો બિલોંગ્સ ટુ સ્ક્રિપ્ટ બી ફોર એવરી બી બિલોંગ્સ ટુ એફ. દરેક બી માટે એ કોમ્પ્લિમેન્ટ એમાં બિલોંગ કરતો હોય તો એ કોમ્પ્લિમેન્ટ બિલોંગ્સ ટુ ઇન્ટરસેક્શન ઓફ બી. Intersection of B is nothing but A script A. A complement belongs to script A. Second condition is also proved. Now last condition, let us take sequence AI in script A. The script A માં હોવું મતલબ intersection of B માં હોવું. Therefore this sequence also belongs to each B. Since each B is sigma algebra of sets, we get એક સરખી પેટર્ન પ્રૂફની. ત્રણે ત્રણ કન્ડિશન માટે એક સરખી પેટર્ન. દરેક બી પેલી ત્રણેય કન્ડિશન સેટિસ્ફાય કરે તો ત્રીજી કન્ડિશન પ્રમાણે યુનિયન ઓફ AI also belongs to B for each B. દરેક બી માટે આ સાચું છે એટલે ઇન્ટરસેક્શનમાં પણ છે. યુનિયન ઓફ AI belongs to intersection of B. The intersection of B is nothing but script A, so union of AI belongs to script A. So all the three conditions are satisfied, 1, 2 and 3. From these three conditions, A is sigma algebra of sets, and also by definition. Definition શું છે આપણી? F ની આવી છે. દરેક બી છે એ સિગ્મા અલ્જીબ્રા છે અને સી ને કન્ટેન કરે છે. હવે આ દરેકમાં સી તો છે જ દરેક બી માં, તો ઇન્ટરસેક્શનમાં પણ સી હોય જ, એટલે એ પણ સી ને કન્ટેન કરે છે. બીજું ઇન્ટરસેક્શન લેવાથી ઓલવેઝ તમને સ્મોલેસ્ટ સેટ મળે. દરેક સેટનો ઇન્ટરસેક્શન લ્યો તમે તો સ્મોલેસ્ટ સેટ મળે, એનાથી નાનો સેટ મળી શકે નહીં જેમાં સી હોય. યુનિયન લેવાથી મોટો થતો જાય, ઇન્ટરસેક્શન લેવાથી નાનો થતો જાય, દરેકનો ઇન્ટરસેક્શન એટલે સ્મોલેસ્ટ મળે. તો બાય ડેફિનેશન ઓફ સ્ક્રિપ્ટ A is the smallest sigma algebra of sets containing C. તો આ જ થિયરમ તમારે અલ્જીબ્રા ઓફ સેટ્સ માટે પ્રૂવ કરવાનું છે. એ તમારું હોમવર્ક રહેશે. તો આજ ફર્સ્ટ લેક્ચર છે એટલે આટલું રાખીએ.